Hey guys, so today we're going to discuss the question called as product of array except self. So this is a Leetcode medium question. So as the title says, product of array, so it's going to be related to something product of array and except self. So by the way, let's start reading the question. So given an integer array, return an array called as answer such that answer of I is equal to product of all the elements of nums except nums of I. So you must write this algorithm in order of n and without using any division operations. So what they're trying to say is, for example, let's take an array. This array is called as nums. So this is the input of the given for a given. This will be as an input. So let's take another array which is called as answers. So now this answer will contain all the product of all the elements except the self. So where answer of I is equal to product of all the other elements except the nums of I. That actually means this will contain the product of all the elements in the array except the current cell, which is 1. So for example, let's take the product of all the elements is 4 into 3 into 2 except this one, so it's going to be 24, right? So now let's add 24 here, so it's going to be 24. So now here the product of all the elements except 2 is nothing but 12, right? So it's going to be 12. So in here the product of all the elements except 3 is going to be 8, right? Similarly here the product of all the elements except 4, it's going to be 6. 3 plus 3 into 2 into 1, it's going to be 6. So this is the answer array. This is what the requirement is. We have to return this answer array as an answer at the end. So what is the first approach which comes to our mind when we want this kind of requirement? So one is a two pointer approach, right? We're just going to do two for loops. We can use two nested for loops, and one would be pointing to the index and the current index, and the other pointer will be traversing the entire array, and we have to make sure we don't multiply the current number, which would be I is equal to j, and we have to find the product of all the elements, right? That would be one approach. So let's try to see how we do that approach. So here we are having an array called as nums which contains the elements 1 2 3 4, right? So let's try to find the brute force approach. So this brute force approach, what we're going to do is we're going to take two pointers. Let's take one pointer would point to, maybe initially both the pointers will be pointing to 0, right? So let's take, this is one pointer which would be I. We'll take another pointer which would be j. So what's the requirement? We have to find the product of all the elements except the current one. So I will be pointing to the current one, j will be trying to find the product of all the elements except the current one where I is pointing, right? So now initially I is equal to j. That actually means we shouldn't have to find the product of, we shouldn't add the current value for the product, right? So what we're going to do is I'm going to use a variable called as product, maybe. So initially it's going to be 1. So now as I is equal to j, we shouldn't add the current one for the product. So now what I'll be doing is I'll be moving this j forward. So this is going to go to 2, right? So now I is not equal to j. So now we have to add the product which is there at j to the product variable. So it's going to be into 2, right? Similarly I have to move the j forward again. So now it's going to move towards the second index. So now this in second index the number which is there is 3. So just multiply 3. So now again the number which is there at 4. So we have to move this again. So it's going to move towards 4. So now it's going to be 4 into 4. Oh sorry, I'm going to use blue for that. So into 4, right? So now the product is going to be 24, right? So don't get confused. I have used 1 here, right? That doesn't mean that I am adding the first value as well. The reason why I have used 1 as a product initially is if I use 0, then the entire product will also be 0, right? For that case I'm going to use 1. Maybe if it is any other element, then it wouldn't be added, right? So for this I have to use 1 because initially product has to be 1. If it is 0, then the entire product is going to be 0 at the end. So that's why I have added 1. So for the first element it's going to be 24. So let's take an array. So this array is called as answers. So it's going to store all the product of all the elements except the self. So in the 0th index the product of all the elements except the self is 24, right? So now we have got the ith index value. So now we have to move I forward. So when we move I forward, j should come towards, I should be at second, the next step j should come back to the first, which is 0, which is at 0th index. So now again, starting from the first, we have to find the product of entire array except the self, which is I. So now again, bring back the product to the 0, I mean the 1. Let's bring it to 1. So now we're gonna find if j is equal to I or not. If it is not equal to I, then actually means we can add, we can multiply to the product. So as they are not equal, I'm going to just multiply it to 1. So now I'll just move j towards the next place. So it's going to be here, right? So now j is equal to I. Now we shouldn't add this value for the product, right? So I'll be moving j forward again. So now it's going to be 3. So j is not equal to 3, so that actually means I can add to the product. So it's going to be into 3. So again, moving j towards the right. So it's 4. So we can add, because I is not equal to j, so into 4. So totally it's going to be 12, right? So now I can add 12 at this place. Similarly, if I find all the elements, if I move towards, if I follow the same process by moving I towards the right and using j for finding the product of all the elements except the ith place, then I'm going to get this kind of array. So now this will be our array, this will be our answer array, and we're going to just return this answer as our answer. So this is what the normal brute force approach is. So as you're trying to do two for loops, like two natural for loops kind of approach, so as we are trying to do for each and every cell, we are trying to iterate to entire array, right? So that actually means for n elements we are going to do n times. So the time complexity is going to be order of n square. So this is the time complexity of it. This is actually a brute force approach. So the first approach which comes to our mind is our brute force approach, right? But this is not recommended actually, because as the question says, we have to write an algorithm which takes order of n time complexity, but this is n square time complexity. So let's try to know how can we do the order of n time complexity approach. So now let's see the order of n time complexity approach. So what is the main intent? How can we get the order of n time complexity? That actually means we have to traverse for each for loop just once. I mean, we have to just do linear traversal, not like a nested traversal like that. So that actually means we can do a linear traversal any number of times. If you do any number of times, even that's going to be order of n, but no nested traversals, right? So if you see clearly, like we have to get the entire product except the current one, right? For example, let's take we are at the number 2, right? So now to get the product of all the elements except the 2, we have to get the left side elements and we have to get the product of right side elements, right? So in this case, the product of left is 1, the product of right is 12. So multiplying the left and right product is going to get the current one, right? The current answer. So even in this case, even in 3 as well, so if I get the entire left product which is 2, the entire right product which is 4, multiplying the left and right product, gonna get the product of all elements except 3, right? This is the main intention. So for this, what I can do is I can create something called as like a prefix array. What I can do is I can find the product of all the left elements, I can find the products of all the right elements, and just take the product of left and right and add it to our answer. That's it. That's as easy as it is. So for example, what I'm going to do is I'm going to take an array which is called as left, I'm going to take another array which is called as right. So now this left array is going to store the product of all the left elements, and this right array is going to store the product of right elements, right? So starting from the left, what I want to do is initially for the first element which is 1, the left product would be just 1, right? Including the current one. So it's going to be 1. So for the right one, for the next element which is 2, it's going to be 2. For the next element which is 3, it's going to be 6, because adding from here, so it's going to be 6, right? So for the fourth, the last element, it's going to be 4 into 3 into 2, 24, right? or maybe I can just take the left of I minus 1 into the current nums of I can just do that. So it's going to be 24 now. So now let's try to take the right product of each and every cell. So starting from the right side, so I can just take, initially it's just one element, so it's going to be 4. So now next one is 3, right? So 3. So what I can do is 3 into 4, it's going to be 12. So that actually means from this cell, if you go towards right, the product is 12. So from here it's going to be 24. So here it's just 1, right? So it's going to be 24. So this is the right product. So now to get the answer, as I said, the formula is going to be answer of I is equal to left of I minus 1, right? Left of I minus 1 into right of I plus 1. This is the formula. This is the main formula. Like to get the answer of I, just get the left product from the left array, right product from the right array, and just add to the answer of I. That's it. So now in the first cell, as we don't have negative index, right, for the left, so we don't have to take the left because 1 doesn't have any left elements. All we have to bother is only right elements. So initially, as we have only right elements, so we just take answer of I is going to be right of I plus 1. So it's going to be 24 in this case. So here now answer of 1, so answer of 1 is going to be left of I minus 1. That actually means left of I minus 1 is 1 into the right of I plus 1 is going to be 12, right? So it's going to be 12 at the end. So now it's going to be 12. So again, the left of 2 minus 1 is 1, which is 2. The right of 2 plus 1, which is 3, which is 24. I mean 4 towards right. So now it's going to be 4 into 2, it's going to be 8. So now again, as the element 4 doesn't have any right elements, all we have to bother is only left elements. To get the left elements, we have to see the left array. So left of 3 minus 1, which is left of 2, is 6, right? So which is 6. So this is the entire answer array. So now we have got the entire answer array. So why is this order of n time complexity? I'll tell you that. Because initially, before finding the answer array, before manipulating with this answer array, we are going to find the entire left array, right? We are going to add entire the left product. For that, it's going to take order of n. So next we're going to find the entire right product, so it's going to be order of n for that. So again, by using this left and right array, we're going to fill the answer array. So for that, it's going to take order of n. So as we're doing 3 times three linear traversals, so it's going to be order of n plus order of n plus order of n. So it's going to be order of 3n. So as we neglect these constants, right, so by the end it's going to be order of n time complexity. So that's why this is order of n. So this is the recommended approach. This is the approach which is required, which the question is actually asking. So now let's try to implement this. Let's try to code this. So here we are having a method called as product except self, which passes as an integer array which is called as nums, and we have to return an answer array. So that's a requirement. So we have discussed 2 approaches, right? One is order of n square, one is order of n. So let's try to implement order of n approach. So what I have used 2 arrays, 3 arrays combined. One is for the left product, one is for the right product, one is for answer. So I'm going to create that. So initially I'm going to create a variable called as n for storing the length of the given num. So if n is equal to 1, this is like a normal edge case. If n is equal to 1, then that actually means it has only one element, right? So one element, that actually means it has no left and right product. So it has only one product, right, which is the current element. So I'm just going to return nums. This is going to be our answer for the array which has size 1. Or else what I'm going to do is I'm going to find the left product, I'm going to find a right product and fill the answer array. So first thing, I'm going to create an array called as left to store the left product of size n. I'm going to create a right product to store the right array of size n. So now similarly, I'm going to create something called as answer, which is going to store our answer. So this is also of size n. So now for the 0th index element, the left product is nothing, right? It doesn't have any left elements, so it's just gonna be nums of 0 only. So this is going to be 0, nums of 0. So starting from the first index, for int I is equal to 0, I is equal to 1, I is less than n, I plus plus. So how do I find the left product of the current element, which is taking the left of the current left, and multiplying it with the current nums, right? So left of I is going to be nums of I into left of I minus 1. So similarly, for the right of n minus 1, for the last index, the right side elements is nothing, right? It doesn't have any right side elements, so it's just going to be nums of n minus 1. So now for int I is equal to n minus 2, so n minus 2, I is greater than or equal to 0, I minus minus. So right of I is going to be nums of I into right of I plus 1, I plus 1. So this is the formula, right? So this is going to create our left product array and right product array. So when we have the left product array and right product array, now it's the time to add answers to the answer array. So for that, for int starting from the 0th index to the n minus 1, what I'm going to do is answer of I is going to be the left side elements and right side elements of ith index, right? So to get the left side elements product, so it's going to be left of I minus 1 into, to get the right side elements is going to be right of I plus 1, right? So this is going to create as the left and right. So now one case is if the current index is 0, it doesn't have any left side elements, right? So this is going to be an edge case. So if the index I is 0, if you try to get left of I minus 1, I minus 0, 0 minus 1, which is minus 1, it's going to create array index out of bound. For that, we have to see this is as an edge case. So what I'm going to do is, if I is equal to 0, answer of I is going to be right of I plus 1, just right side elements. Else if I is equal to n minus 1, answer of I is going to be left of I minus 1. Else this is the case. If we have left and right elements, then we can do this normal case, or else just the top cases. So at the end, we're going to get the answer array and we have to just return answer at the end. So this is an order of n approach, right? So for this loop, so for this for loop, this is going to take order of n, right? So the second one, this is the one, so this is going to take order of n, right? So this is the third one, so this is going to take order of n. So there are 3 n time in order of n traversals. So by the end, it's going to be order of n time complexity. So this is pretty much the implementation of it. Let's try to run this. Yeah, it worked. Let's try to use some extra test cases as well. Yeah, let's try to submit this. Yeah, it got succeeded. So this is how you find the product of array except self. So initially I have tried like when I was doing this problem for the first time, I have tried the order of n square approach. So you can see it clearly here. So it worked, it got succeeded, but it took more time, 1929 milliseconds. This is the n square approach, but later I have used order of n approach, so it's just 1 millisecond. See how much difference it is. So yeah, so this is the order of n approach. So if you like the video, please make sure you like and subscribe. Thank you.